This is build 122 of Rootwoven on our Galaxy tablet. I tap a dialog field, type hello, and the text reaches the game. Technically, it works. But while I type, Unity adds this bright white field across the screen. The game is still behind it, the native keyboard is still below it, and suddenly the whole experience feels like filling out a form. This is build 123, the same tablet, the same dialog, and the same word. The native keyboard is still here, but the extra field is gone. Rootwoven remains the place where the text lives, and the game rearranges itself around the space the keyboard needs. This was an awkward kind of problem. Text entry was not broken enough to reject, but it was visible enough to pull the player out of the game every time they typed. Fixing it meant keeping Android's keyboard, removing Unity's extra field, and making our UI respond to the space that remained. The first useful distinction was that the white strip was not the keyboard. Android calls the phone keyboard, and the system that sends its text into an app an input method editor, or IME. That is the only keyboard acronym we need. The important part is that a native keyboard is much more than a grid of letters. It handles languages, words that are still being composed, selection, correction, emoji, voice input, and accessibility behavior. Those are mature expectations, not decorative extras. Our problem was not Android's keyboard. It was Unity's extra field between the game and that keyboard. Even so, our first idea was to draw a Rootwoven keyboard ourselves. We built that prototype in 1JS, the UI layer we use for Rootwoven. Visually, that direction was attractive. Every key could belong to the game, and no white system field could interrupt it. But drawing the keys was the easy part. Shipping them would make us responsible for everything around them, composing text in different languages, moving the cursor, selecting and pasting, suggestions, emoji, voice input, and accessibility. We would also be asking players to abandon the layout and assistance they had already chosen on their device. A custom keyboard would have made Rootwoven responsible for years of platform work in order to remove one unwanted visual layer. We stopped that experiment before it shipped. The native keyboard was not the part we needed to replace. The extra field, and the game's reaction to the keyboard, were. On Android, an activity is the part of an app that opens its main window and handles events such as launch, pause, and resume. The older build, the one with the white field, used Unity's standard activity. The current build uses Unity's game activity. That newer entry point uses Android's game-oriented path for moving text between the keyboard and the game. Unity calls that path Game Text Input. One documented behavior mattered immediately to us. With game activity, Unity keeps its extra input field hidden. Android still provides native composition, selection, and keyboard behavior, but the white strip no longer has to sit above the keyboard. In the Unity project, the visible change is almost comically small. One saved setting changes from activity to game activity. But that setting controls how Android starts and hosts the game, so it is not a cosmetic toggle. Plugins, sign-in, pause, and resume can all cross that boundary. That is why the change still required basic checks in pre-release builds and on real devices. Most importantly, this switch solved the extra field. It did not solve the layout. Removing a strip still left a native keyboard occupying a large and variable part of the display. We had removed the form. Now Rootwoven had to understand the space that was left. A phone keyboard does not reserve one universal rectangle. Its height changes with screen size, display scaling, navigation buttons, the chosen keyboard, its suggestion row, language, and whether a foldable is open or closed. A foldable can even split the keys into two islands. The game cannot learn all of those shapes from one preview window in the Unity editor. Android does know where the keyboard begins. A small controller passes that measurement into Rootwoven's interface. The game can then treat everything above it as usable space and keep the active field and important actions inside that region. Our first layouts were not graceful. The message navigation controls competed with the text field. Icons and the text field could jump when the keyboard measurement settled. A single rule that said, "Move everything upward," only moved those problems. So the Android views gained explicit layout decisions. When space is tight, non-essential framing gives room back to the conversation. While the player is reviewing or waiting for an action, the controls that matter remain reachable. The dialogue background and bottom framing cover the newly exposed shape instead of assuming the old full-height composition. This is the custom part of the final solution, not the keyboard, but the way Rootwoven responds to the real keyboard that appears. Hiding Unity's field removed the interruption. Measuring the remaining space made the result usable. Editor tests still matter. We can give a test a precise keyboard height, check where the dialogue and controls should move, and repeat that state in seconds. Those tests are fast enough to run while changing the layout. But the Unity editor cannot prove which Android activity launched. It cannot show a real device keyboard, measure how much of the screen it occupies, or confirm that a tap on the complete device display reaches the intended field. Even a screenshot taken only inside Unity omits the keyboard because Android owns it. We therefore built a small Android test app called the Keyboard Visual Lab. It opens the real native keyboard, sends text through Android, checks that the text reaches both the visible field and game state, dismisses and reopens multi-line fields, and saves an image of the complete display. The test app runs without login, online game data, downloadable content, or usage reporting. That does not make it the production game. It makes a keyboard failure easier to interpret. The activity, keyboard, layout, taps, and capture path are present, while unrelated online services are not. That gave us two loops: repeatable layout states in the editor, then the real Android boundary on displays we could vary. Before paying to run the tests on a wider set of real phones and tablets, we did a broad, local check. 5 virtual Android devices represented an older 16:9 phone, a tall budget phone, a mainstream cutout phone, a large tablet, and a foldable inner display. Our connected Galaxy tablet ran beside them. Each target exercised 4 scenarios. 5 emulator profiles and our tablet passed all 24 captures in this local pre-flight. This dashboard came from a working copy that still had uncommitted changes. That is useful process evidence. It shows the fast, broad loop we used while the feature was still changing. It is not the final device run tied to a clean commit, and it does not mean every emulator run before or after it was green. That local check showed the layout working across varied virtual screens. Before moving to more real devices, we also needed to define exactly what a passing capture had to prove. Before using the lab as final evidence, we tightened what counted as a valid capture. Seeing the app on screen was not enough. Every capture had to prove that game activity was running, the device's software keyboard was stably visible and occupying measurable screen space, and the active field and controls remained usable. Entered text had to reach both the interface and game state. Multi-line tests also had to survive closing and reopening the keyboard. If any part of that evidence was missing, the capture failed. Only after the lab enforced those rules did we run the tests on the selected physical devices. The final run used 10 selected physical devices and 7 scenarios per device. 70 complete display captures. The oldest device was a Pixel 3 running Android API 28. The selected list also included conventional Google and Samsung phones, a budget device, 2 tablets, and Google and Samsung foldables, up through API 36. Here is the same multi-line dialogue scenario on 3 deliberately different displays. The Pixel 3 is an older, conventional phone. The Galaxy Z Fold 4 presents Samsung's split keyboard across unusual geometry. The Galaxy Tab S10 Ultra gives the game a much larger tablet layout. The UI has the same job in all 3. Keep the active field and its actions in the usable area above the keyboard. Every archived capture confirms game activity was active. A software keyboard occupied a real, measurable part of the screen. The field and controls stayed inside the usable region. Entered text reached both the interface and game state, and multi-line flows survived dismissal and reopening. All 70 captures passed those checks. Passing was not the same as looking approved. A person also reviewed each full-screen image, including the keyboard and surrounding layout. All 70 were manually approved, with 0 missing captures and 0 device errors. This is strong evidence for a deliberately varied list of 10 devices. It is not proof for every Android device, every keyboard, or every possible configuration. The value is that the coverage is visible and specific. We can say exactly what we checked, what passed automatically, and what a person actually saw. Then we can leave the dashboard and return to the only comparison the player ever experiences. The first build was functional. I could tap the field, type hello, dismiss the keyboard, and continue. That is exactly why the white strip was easy to tolerate as a technical detail. But platform work is part of the game's presentation. If typing turns a conversation into a generic form, the feature works and the experience still loses. We did not solve that by pretending Rootwoven could build a better keyboard than the one already on the device. We let Android remain good at native text entry. We used Unity's game-oriented activity path to remove the extra field. Then, we made Rootwoven responsible for its side of the boundary, measuring the occupied space, protecting the active controls, and testing the complete display across a selected range of real hardware. The most noticeable platform work is often successful when the player stops noticing it. The keyboard still appears. Typing now feels like part of the game.